Alright, so today what we're going to be doing is doing some actual graphing of parametric equations. In order to do that, I'm going to be graphing it by hand. We're going to show that graph on the calculator so we can kind of compare the two. And then to see the actual equation, we are going to be eliminating the parameter and kind of seeing what this graph looks like in that function form. So I have three of these that I'm doing from your worksheet. So obviously you won't have to do those later. So I'm going to start with number 3, as you can see here. And again, the process that I'm going to go through is I am going to start with our table, a table of values, which again has those 3 variables, the t, the x, and the y. So I'm going to make a table real quick, and we're going to plot some points. So you'll notice with this equation, this parametric equation, our t-values are from -2 to 3. So we're going to go -2, -1, 0, 1, 2, and 3. So we're going to plot each one of these guys and see what we get. So I'm going to start with that x value. I'm going to plug in, or not that x value, well, the x value. I'm plugging in the t value for x. So we're going to have our first equation right here, which is going to be -2, which is 4 minus 2, and that's going to give me this first x value. So that's going to be 4 minus 2 is 2. And then I'm going to plug that t value into my second equation. So that's going to be y equals 3 times -2, so -6. So there's that first equation. All right, the second one is going to be a -1, so that's going to be, again, plugged in up here. So -1 squared is 1 minus 2 is -1. Then I'm going to plug in -1 for t, so to give me my y value, so that's going to be y equals 3 times -1, so -3. Next up, I'm plugging in 0. If you plug in 0, this goes away, so you get -2. Plug in 0, this whole thing goes away, and it equals 0. So y is 0. Alright, keep going down the line here. Plugging in 1 now. So I'm going to go 1 squared, so 1 minus 2 is -1. Plug in 1 here, 3 times 1 is 3. And next up is my 2, so I'm going to go 2 squared, so 4 minus 2 is 2. And 3 times 2 is 6. And then finally plug in my 3 value, so that's going to be 9 minus 2. Looks like a time, so that's going to be 7. And we have 3 times 3, which is 9. So I'm now going to take these points, we're going to go ahead and plot them. Do my best to graph this. Let's see, I gotta go left 2, so I'm going to do that. And I gotta go up 9, so I'm going to need some space here. So I'm going to need a bigger graph, but I'll be okay. Let's make it as big as I can. All right. So I have my points, and I'll adjust my graph as needed. But the first point we're going to have is going to be when t is -2. So we're going to start at 2, -6. So 2, and then down 1, 2, 3, 4, 5, and 6. So I'm going to take this. I'm going to need to move it here. If it lets me, I don't think I can, so I'll just have to deal with it. That's fine. I'll take my graph. I will just move it over here. Give me some room. My work will be out of order, but that's okay. Alright. That gives me the extra space I need anyway, so that'll be fine. So the first point, again, is 2, -6. So right 2, down 1, 2, 3, 4, 5, 6. Puts me right there. My next point is -1, -3, so -1, 1, 2, 3, puts me right here. Then -2, 0, puts me right there. Then I have -1, 3, puts me up here. And 2, 6, puts me right there. And finally, 7, 9. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 5, 6, 7, 8, 9. Puts me right at the top of that page. It barely fit, but I got it to fit. So again, when we graph this, we are going, it's about the direction that I'm traveling. So it looks like we got a part of a sideways parabola here. So we graph it and we draw our arrows to dictate the direction of this curve. So there we go, that's our graph. So again, that's what the graph looks like, and if I wanted to eliminate the parameter, we can kind of see what equation that would give us. So again, this is not a trig function, so we are going to eliminate the parameter by taking our first equation, our x equation, and solving that for t. So that's x plus 2 equals t squared, and t is the square root of x plus 2, and it is plus or minus technically. And I'm going to take that, I'm going to plug it in for my y equation. So y equals 3t. So I'm going to just right now say the square root of x plus 2. I know it's plus or minus, so if I simplify this, I get plus or minus the 3 square roots of x plus 2. So again, if I was going to graph this like an equation, what I would have is I would have my positive square root, which is this guy, and I'd have my negative square root, which is this guy. Again, I'm only graphing portions of it based off my my parameters here. So anyway, you can also write this. This is a sideways parabola, so if I was going to take this equation and say I wanted to square both sides, well, before you square both sides, we are going to have y over 3. I'm going to isolate the radical, and this is if I want to write it as a conic section. So I would square both sides, and that would give me y squared over 9 equals x plus 2. And if you subtract 2 from both sides, you're going to get x equals 1/9 y squared minus 2. And you can look at it as a conic section in that form. So again, regardless, you can kind of see it as a sideways parabola. It's kind of showing, like if we're looking at, this is the one we've been doing the most of lately. You can see it, you know, it's a sideways parabola and it's going left 2 because that is my h value, that minus 2. So that all shows up in my graph. So that's what that looks like. Now you can also do this on your calculator, which I have right here. If you're going to graph this, you would go, make sure first off you are in parametric mode, go to your y equals screen and type these equations in. This is how you check your answers as well. So I'm going to have t squared minus 2 for your x and 3t for your y. Now before you graph this, we want to set our t values here. Our t min is supposed to be -2 to 3, so I'm going to change that to a -2. And then here, if you don't know what the graph looks like at first, what you can always do is just go to your table, and your t values, again, we're going from -2 to 3. So you see the smallest x value is -2. So that's my t min. My t max is going to be 7. That's as far out as it gets. So if I go back to my window, I'm going to go -2, and I can go as far as 7. That'll show everything I need. If you want to show a little bit more to show that it actually does stop, I'll go -3 to 8. So you can see that it doesn't go beyond that point. And the x scale 1 is fine. Now for your y values, again, we already know what that looks like. I can go to my table again, but I know it goes from -6, I believe, to 9. So I'm going to go -7 to 10, so you can see everything that's already there. Okay, so, and again, I got my scale of 2, I guess. That's fine. All right, so when we graph it, you pay attention also to the direction that it's going, but it should match what we have, which it does. And the direction matches also. So that's your graph on your calculator, so you can check all these graphs. If you're ever asked a graph, plug it into your calculator. You can see what it looks like, but also obviously know how to do it by hand. Okay? All right, so next up is number 5. We're dealing with some trig functions, and we're going to do this in degrees. You'll see the t-step is going to be 15 degrees. Now again, I'm going to graph this by hand. I'm not going to plug in every single point. You know, a t-step of 15 degrees, that's a lot of points to plug in, but we'll just plug in a few and we can kind of connect the dots properly. So I'm going to kind of do this graph by plotting points, as I said. All right, so I'm going to get that drawn here. That is really bad. I'm going to fix that. Okay. So you got your table. We're going to go from, it looks like t min is 0 and t max is going to be 360. So I'm going to go by 45 degrees 45-degree increments. So that's 45, then 90, 135, 180. Again, there's still going to be a lot of points, but you know, it could be worse. So I'm going to keep this going down the line here. So now I have 225, and then 270, and then I have 315 and 360. And we're just going to plot some points and see what we get. So on this one, we're doing cosines are my x's and sines are my y's. So if you plug in the cosine of 0, think of your unit circle, you're at 1. And actually you're at 1, 0, so we can plot both of those points at the same time. 45 degrees, that's both radical 2 over 2 and radical 2 over 2. Again, I'm just using the unit circle. At 90, you're at the point 0, 1. And then we're at negative radical 2 over 2, radical 2 over 2. And then we're at negative 1, 0. Again, if you are picturing the unit circle in your head as we do this, you note I'm just going around the unit circle. So if I fill in the rest of these points, you should already know what they are if you know the unit circle. Those are negative radical 2 over 2's for both. Then I'm going to be at 0, negative 1, radical 2 over 2, negative radical 2 over 2, and then 1, back to 1, 0 again. And again, unit circle, if you're looking at the unit circle as you fill in these points, you'll see it's just the points on the unit circle. So if you're going to graph this, probably should already know exactly what we're going to get. If you don't, well, I'm about to fill you in. So let me make that a little bit better here. There we go. All right. So our points are going to look something like this. We're going to have 1, 0. So let's call that 1, 0. We also have 0, 1. We have negative 1, 0. And we have 0, negative 1. And we have those points in between. So those points in between, you know, they're going to it's not going to fit perfectly. I know those aren't the points, but you know, I'm just trying to make this circle. So I know those points kind of go in between those radical 2 over 2, radical 2 over 2. And your graph is, again, a circle. So I go around the circle here, and again, note the direction that we're going. So we're going to put the arrows in there. And there you go. So on number 5, we basically have the unit circle. And again, if you're going to eliminate the parameter on this, this is a trig function. We're going to use trig identities. I would assume most people would use sine squared theta plus cosine squared theta equals 1. And if we do that, we're going to plug in, you know, obviously we have cosine of theta is our x, so this is going to be basically x squared. Your sine of t, that is going to be your y, so we're going to substitute that for y squared. And if you think about it, you know your conic sections, that is a circle with a radius of 1, and that's the unit circle in parametric form. So that is your equation for that one, and again, we can graph this, not a big deal. Again, just plug in everything that you're being given here. First off, your equations, you have cosine t. So cosine t, you have sine t. And once you have those, we want to get go to our window. Our t min is 0. Oh, by the way, before I do this, let's go to mode. I am in radian mode right now. I'm going to need to change that. Make sure you do that as well. Back to your window. All right, so our 0, our t-min, our t-max is 360. I'll keep my t-step the same. That's a pretty decent speed that we're going there. Our x-min is going to, in this case, you're going left 1. So we're going to go negative 1 to 1. So negative 1 to 1. Go scale 1, that's fine. Y-min will be negative 1 to 1 as well. And we should be good. I'll make that 1 also. All right, and then when you hit your graph, you'll see we're going to start at that 1, 0. We should be going around in a circle if I didn't screw anything up. And we should be good. I think I made that t-step a little too slow. So anyway, it is graphing. So as I'm kind of going on to the next problem here, we'll see that graph. I'll let it graph, because why not? There's just a lot going on with it. So anyway, as you get this, and I know it's said for your windows to be -2 to 2 on both of these. I did -1 to 1. I mean, just again, the only reason I did that is that's all we needed. I knew it was a circle, so I know it's only going to go up to 1. But if you do -2 to 2 for both, it's just the circle's kind of more, it's smaller inside your window. No big deal though. Now this last one's more just one that's kind of neat looking. We're not going to really plot this. This is going to be all in the calculator. So anyway, what you need to do is just, you know, and like I said, you'll notice this is not any of our conic sections. So if it's not one of our conic sections or a graph that we are comfortable graphing, I'm not really going to force you to graph it by hand. So a calculator is going to get this one. So anyway, we're going to plug in our x and our y values. Let me pause the video, and then when this is done, you can see the whole circle just because. And there you go, ta-da, we got our circle. So now that that's finally graphed, let's go ahead and let's do this cool one. I said this one is cool, so it is cool. So we got to go ahead and change our x and y values. So let's get these plugged in with our new values. We have sine t. So sine t minus t cosine t. Your y value. We're going to go cosine t and then plus t sine t. A lot of t's there. Okay, and then your window, it's all set up for you here. So we're going to go t min, and this one we need to be in radian mode. So we're going to go to radian mode. Unless you want to convert all those manually, I'm not going to do it. So I'm going to go t min is 0 to 4 pi. So we're going to do 2 periods here. And let's see, our t-step, pi over 12. X min, in this case, is going to be -12 to 12. So I'm going to go -12 to +12. Again, just filling in everything they're giving us here. And y is -12 to 12. And I'll go by 2's here, because that's a lot of points. So -12 to 12 again. Again, those x scale and y scale don't really matter. I just don't like to have a ton of tick marks. All right. So first off, let's look at this graph. See what we got here. And there's your spiral. So we got a cool little spiral going on. And again, what's happening is we are trying to graph a circle, but as we plug in higher numbers, our radius starts to grow. So that's really what's happening. So we're graphing a growing circle, which is what a spiral is. The algebra behind it is a little tougher. I'm not going to ask you to eliminate the parameter on this. Not that you couldn't do it, but again, this would be testing something that is purely calculator. I still want the points. I want the direction and all those things. So in order to get that, just go to your table. So if I did the table, I'm going to just pick a few points, and we can go ahead and get this graph on our paper with the proper direction. So we still are able to do that. So this graph, again, it starts, in this case, from t min of 0 to t max of 4 pi. So we're going to graph this. Again, you can go to your table setup. And again, what I want to do is, in this graph, we are starting at 0. And I want to be able to plot some points. And these points are really ugly looking, but if you understand what you're doing, it's really going to help you out quite a bit. Now I'm trying to go by from 0 to 4 pi, so I'm going to graph this in increments of pi over 2. So this tells me every point on my graph is pi over 2 radians. So when you go to your table, this first point is 0 radians, and then pi over 2 radians. And this would be 2 pi over 2 radians, and so on. So we're going to plot these points, 0, and then pi over 2. 2 pi over 2 is pi. You'll see that third point is 3.14. And then 4 pi, so pi over 2, 2 pi, so 3 pi over 2. Then 4 pi over 2 is 2 pi. And again, I'm going all the way out to 4 pi. So that's 5 pi over 2. 6 pi over 2 is 3 pi. 7 pi over 2. And 8 pi over 2 is 4 pi. So again, that's what I'm looking for. Is I'm looking for a table, and you have to give me the points in terms of pi, which is what I did. You can be more detailed if you want, but this should be plenty. And as long as you can see your curve from here, we're okay. So I have my points. I'm going to plug in 0, which is 0, 1. My next one is 1 and then 1.5. I know these are actual values, but again, as we're plotting these, it's 1.6 if you're doing it. If you're just plotting points, this is going to be fine with the decimals, because you have to plot this on a graph. So the decimals are good, even though you may have some radicals and things like that. That's not going to help you graphing it. So this is going to be fine. Like this is negative, or this is still pi, but as I said, when you're graphing it, 3.1 is fine because you have to know where to put it on your graph. So 3.1, negative 1. Keep going down, negative 1, negative 4.7. Then we have 2 pi, so that's negative 6.3. And 1. Go down a little bit more here. And I have 1, 7.9. And then that's 1, 7.9, and then 9.4, negative 1. I have 2 more, negative 1, negative 11. And last one is negative 12.61. That's a decimal point right there. Okay. So this is going to need a lot of space, so I'm going to go ahead and get this. But again, there's nothing else I'm going to do here but graph this. So if you look at your x and y values, my x values, I have to go left 12. My y values, and again, it just goes from negative 12 to 9, so I need that space. My y values just go from negative 11. My highest value is going to be 8. So I'm just going to try to make this as even as possible and see what I get. It's a little off. Move it down 1, and if I have to adjust it, I'll do what I got to do. Okay, so just plot these points, and that's how you would finish this. So we got 0, 1, and 1, 1.6. So we got 1, 0, 1, then 1, 1.6, and 3.1, negative 1. And again, remember, as you're doing this, you know it's a curve. You know what direction it's going. And I'll just start it, but we'll finish it later. So next up is negative 1, negative 4.7. Negative 6.31. One, 7.9. 9.4, negative 1. Again, that was 9.4, negative 1. Again, keep the spiral going. It's going to slowly grow. I mean, just do the best you can with it. And again, it's all about the direction as you do it. So keep track of the direction. You got your arrows as you go. I may start running out of room here. I'm not going to rearrange everything at this point, but we'll just fit it as best we can. Negative 1, negative 11. I don't think that one's going to fit. So negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Somewhere down there is 11. Negative 11, and then negative 12.61. Negative 5, 6, 7, 8, 9, 10, 11, 12. So negative 12.61 is going to put me about right here. So there's your spiral. So again, you're doing this by hand. That's how you're going to get her done. Okay, and again, the arrows kind of tell you where to go. And there we are. So you got your growing spiral. So all you need to do at this point is be able to finish these. Now again, the only ones, the only one that I really want to do the only ones that you have to do solely on your calculator are going to be these crazy ones. But otherwise, if we're going to eliminate the parameter, I'll kind of clue you in on which ones are which and whatnot. But work through 1 through number 10, and again, use your calculator to check your work, and you should be good.